Good evening, sir.
Good evening, sir.
We are first supposed to discuss exercise 5, right?
Yes, sir.
Exercise 5.
So 16.
52, 53.
52, 53.
16.
60.
No, sir, 16.
ये कौन है भाई? स्पैमर है क्या?
So 1616.
16. The doubts were taken up to 34 in the previous doubt lecture. Up to 34 we have done in the previous doubt lecture. Yes or no?
Yes.
Yes, sir.
Yes, sir.
ये भाई अभी बीच में उठ के 16 क्यों बोल रहा है? Recording of the doubt lecture also was sent. Up, it appears like every time I start again, I start from the first problem. We will never go ahead.
तो 54 में डाउट है, 52 में नहीं है.
52 में भी है.
54.
45.
42.
50.
50. 50.
38. Have a look at this. Disk of mass, and consider that to be a particle over a smooth horizontal surface with velocity v experiences a perfectly elastic collision with a smooth stationary wall at point O. Angle between the motion of direction of the disk and the normal to the wall is equal to alpha. Fine. Find the point relative to which angular momentum m of the disk remains constant in this particular process. Right. Now this is a horizontal surface. Particle is coming this way and it goes this way. This is alpha, this is V. Right? Now in this process you are telling me point relative O dash. This is O, this is O dash. Now it comes and it goes this way. Am I right? Point relative to which angular momentum m of the disk remains constant in this particular process. Second, magnitude of the increment of the vector of the disk angular momentum relative to the point O dash, which is located in this particular plane. Now observe this. If I take the point O dash, angular momentum will remain 0 all throughout. If I take the point O, angular momentum all throughout the journey, whether it is coming or going, will remain 0. L about O will be 0. Do you agree with that? Point relative to which angular momentum of the disk remains constant in whole of this process. You take any other point here. Extend the line and drop a perpendicular on it. After collision, extend the line and drop a perpendicular on it. Right? So, angular momentum about O will be 0 all throughout. This point of AB is clear to all.
Yes, sir.
Now, when you are speaking about O dash, you are asking me magnitude of increment of angular momentum of the disk relative to the point O dash. Is this elastic collision? Yes. If it is elastic collision, this angle will be alpha and this speed will be V. In a perfectly elastic collision, kinetic energy should be conserved. So obviously the speed will be V. Now about O dash, have a look at it. I will take this as B cos alpha, this will be B sin alpha. Right? if this length is given as L, just before collision, L initial, just before collision, you are asking me the magnitude of the increment of the vector just before collision, it will be m v cos alpha into the perpendicular distance L. Now just after collision, now this will give me clockwise about O. Clockwise I am taking positive, anti-clockwise. Now v sin theta I forgot. M v sin theta, M v sin alpha just before collision. V sin alpha is this way, so it becomes 0. Just before collision, this point will become 0. Just after collision, this has a velocity this way and this way. This velocity will give me 0. This will give me mv cos alpha. Right? mv cos alpha into L. Now about 2 dash, this will be anti-clockwise. This will be clockwise. This will be anti-clockwise. Right? Minus of minus. See the directions properly and add both of them. What is the answer given for the 38th? Yeah, I directly put negative positive sign. Very technically, you should put a negative sign and negative sign. Final minus initial, and they are in opposite direction. 2mvl cos alpha. They're just playing with you people. Small silly problem, but make you look very complicated. Can I rub the board?
Yes. No. 42. Force is given as AI cap plus BJ cap is applied to a point whose radius vector relative to the origin of the coordinate O is equal to R is AI cap plus BJ cap. F is given, R is given. Hey, torque पूछ रहा है यार. कर क्या रहे हो आप लोग? Find the moment N and the arm L of the force relative to the point O. Torque is R cross F. Torque is R cross F. This is R. R cross F clockwise. Yeah. Take the cross product. Cross product लेना आता है. And then equate this to magnitude of F into L. Whatever you are getting, magnitude of F यहाँ डालो. You will get L, that is R perpendicular. Do you people recollect? We used to call this arm length. This is L. This R sin theta is technically L. Right? L will be R sin theta. So whatever you are getting equated to the magnitude of F into L, you get the value of L. Cross product होगा आपसे.
हाँ सर.
Can I rub the board?
Yes, sir.
Now, 45. See, he placed a ring this way. It was initially having an angular velocity omega. In the question given, coefficient of friction is taken as k. We are comfortable taking it as mu. We'll continue with mu. Right? So, mu n into r is d2. So if I want mu n into r, friction will be acting. Suppose I see the top view. This is given an angular velocity omega. On this, friction will act this way. Right? Mu n is dm into g into r is d2. Integrate this, you will get torque is I alpha is mu mg into r. Alpha is mu mg into r divided by m into r square. Mu g by r is alpha. Once I have alpha, you are asking me how long will the ring. Now this alpha is constant because ring is slipping. It's made to sleep on the surface. The ring is made to sleep on the surface. So it is slipping. The omega is in this particular direction. This is the top view. This is the top view. So omega is equal to omega naught minus alpha. Final is 0. T is omega naught by alpha. Substitute this alpha here, you get the answer. This is for the first bit. First bit is easy, not difficult. What makes it difficult is the second bit where the disk is taken. For a disk, integration will not be this easy. Here, integral dm you directly put as n. Clear up the board. Go to the second bit of 45. Now 45th B bit, what happens is it's a disk placed this way with an angular velocity omega. Omega naught, whatever it is. Omega naught. Now consider an elemental ring n of radius x and thickness dx. D tau will be f into x. F on it will be mu dm into g. Frictional force into distance is x. Mu dm into g. Dm will be the mass of the complete ring. Mass per unit area pi r square into 2 pi x dx. This is dm which you should understand. This is the key catch. dm of the ring. Now this ring, if you see from the top view, it's rotating in this direction and on this friction will act this way. So torque will be friction into r. R is x.
R is x, mu dm into g into x is the torque. Dm is mass per unit area into area of the ring. Integrate this, you get the answer. You get torque. Once you get torque, equate it to I into alpha. I is mr square by 2. Once I have alpha, I will be able to calculate the time after which it comes to rest.
Thanks, sir.
Now, question number 50 is a typical problem from Mirado. Problem for the sake of problem. You are pulling this way. Center of mass will be somewhere here. Center of mass will not be the center of the disk because they have given this also to be M2, this also is M1. M1 is here. M1 and M2 ka center of mass will be here. You are filling this with a force of F. This point is called as some point called Q. So your first equation F is equal to M1 plus M2 into acceleration. Acceleration will be the acceleration of center of mass, not the center of the disk. Then F into R is equal to I into alpha. I will be that of only M1 R square by 2. And then acceleration of this will be R alpha with respect to the center. Acceleration of this will be R alpha with respect to the center. Plus acceleration of the center will be equal to acceleration of K. This point and this point should have the same acceleration. So this is my first equation. This is my second equation. This is my third equation. Coming to the kinetic energy of the system, delta Ke I will write as half M1 plus M2 into AT whole square VCM plus half I into omega square. How much will omega be equal to? This will be alpha. How much will I be equal to? M1 R square by 2. Or you can calculate this directly from F into X. F into X. Either this or work done will be equal to F into X. F into X is half AT. Either this or that. Use any one of the formula, you get the answer. Now there is a beauty. Recollect in work energy theorem, we told you one very important point. Work done is force dot displacement. Displacement must be the displacement of the point at which the force is applied. Yes or no?
Yes,
Now,
sir.
this will be AK. Acceleration of this K. This will be AK. Why will you take acceleration of K? You are applying force at that particular point. Don't take the acceleration of the center of mass or acceleration of this or anything else. Whichever point you are applying the force, displacement should be the displacement of that point.
So can you explain the third equation again?
Acceleration of this with respect to this point is r alpha. Plus acceleration of this point with respect to the ground is acceleration of this point with respect to ground.
Yes, sir, got it.
If not, have a look at it. If you can find out this distance, then acceleration of this with respect to center of mass will be x into alpha. Plus acceleration of center of mass with respect to ground, I'll get the acceleration of this point with respect to ground. Either way you can solve. Finding out the position of center of mass is not difficult for you. You'll be able to do that. Right?
Yes.
No, sir. How will you find the height of center?
So how will we find M2?
Okay, M2's position is not given, right? So you'll not be able to find out the position of center of mass. Height of this M2 is not given.
Ah, sir. Why?
So center of mass will not come. So go with A1. I know the distance of this front. If not, he should give you the height of M2 so that you know the position of center of mass of M2. Once that is known, M1 is known, finding out
then we'll
center of mass will not be difficult. Can I rub the board?
Yes.
$52. Cube at J rests on a horizontal table. Right? Whose friction coefficient is mu. The cube is set into motion with an initial velocity, travels some distance over the plane and comes to standstill. Explain the disappearance of the angular momentum of the cube related to the axis lying in the plane at right angles to the cube's motion direction. Axis lying in the plane. Somewhere I believe this is the axis, cross perpendicular this way. This was u, right? So you had initial angular momentum mu into r. He says there should be a torque. 100% there is a torque here. Angular momentum will change dl by dt. When this came to rest about this axis, initially it had mu into a by 2. L initial is mu into a by 2. L final is 0. So there is a change in angular momentum. He is asking, please explain why did the angular momentum change? Because there is an external torque. What makes you think there is external torque? Friction is acting, passing through this point. Mg is in this direction. But normal force is not at the center. Normal force has moved up to the right. Why? because normal force should counter the torque due to friction. So normal force went to the right.
Yes.
About the center of mass, normal force and friction are cancelling out the torque. So normal force will shift to the right. Now, about this axis, friction gave me zero torque, but mg and normal force together will not give me zero torque. They may be equal, but their perpendicular distances are different. So net torque is not zero. If torque is not zero, there will be change in angular momentum.
Yes, and the torque will disappear when it comes to standstill because N will come in the line of mg.
Perfect. Find the distance between the resultant of gravitational force and the reaction force extended exerted by a supporting plane. In the
180.
second line, they gave you the hint for the first question. Now, distance means you obviously know what is this distance x? Friction into a by 2 should be equal to n into x, because normal force and friction should cancel out the torque.
तो वो HCV के क्वेश्चन जैसा हो गया मेरे क्लास में कराया।
Pardon?
वो आपने क्लास में कराया था HCV का क्वेश्चन ऐसा ही इंक्लाइंड प्लेन पे नॉर्मल फोर्स शिफ्ट होता है।
We did something similar.
हाँ डन सर।
'53. A thin uniform square plate with side L and mass M can rotate freely about a stationary vertical axis coinciding with one of its sides. Stationary vertical axis coinciding with one of its sides. Small ball of mass M flying with a velocity v at right angles to the plane strikes elastically at the center of it. Fine. Velocity of the ball v dash after impact. The horizontal component of the resultant force with the axis will exert on the plane after the impact. Hey, listen. I will not solve this problem completely. Please observe this. This is the axis. A ball is coming and striking here. Right?
Yes sir.
Yes, sir.
Because it is fixed about this axis, there is an external force. I cannot conserve linear momentum. Do you agree with that?
Yes,
हाँ
sir.
But about this axis, I can conserve angular momentum.
Yes.
हाँ torque zero।
What is the initial angular momentum? Mass of the ball into the velocity with which it is coming into this perpendicular distance about this axis is initial angular momentum. Mass of the ball into the velocity with which it is coming into this perpendicular distance.
Yes, sir.
Yes sir।
Now, final angular momentum. Mass of the ball doesn't stick to it. It is elastic quality. Final angular momentum, mass of the ball into V dash into L by 2 plus angular momentum of this particular disk I into omega. This is a square plate. You know the moment of inertia about this. M A square by
12
parallel axis theorem.
ml square by 3।
Now I know M V dash into A by 2 plus I into omega. You get second equation will be small e. Relative velocity of separation upon approach at the point of contact. Do I know the velocity of the center of mass? Yes. A into omega, A by 2 into omega. R into omega. I know the velocity of this.
हाँ
I know the velocity of the ball. Initially is V, finally is V dash. Will I get my answer?
Yes.
yes।
54. A vertically oriented uniform rod of mass m and length L can rotate about its upper end. A horizontal flying bullet of mass m strikes the lower end of the rod and gets stuck to it. The rod swings through an angle of alpha. Assume that m is much smaller than capital M. Find the velocity of the bullet. Conserve angular momentum about the hinge. O. Hey, 54th में doubt क्या है? If 54th में you have a thin rod this way, there is some mass coming and striking here. Conserve angular momentum about this. This is capital M. This is capital L. Small m. Rotate about its upper end. Horizontally flying bullet of mass m strikes this and gets stuck to it. As a result, velocity of the flying bullet, conserve angular momentum about this particular point. After collision, you are telling me it sticks to it. Let it stick. I will be moment of inertia of the rod plus moment of inertia of this I omega. At what distance x from the upper end of the rod the bullet must strike for the momentum of the system, bullet and rod to remain constant during impact. Momentum should remain constant means, listen, I'll give you the hint. You must have had a problem with the C bit only. For the horizontal momentum to remain constant, Nx should become 0. We have done this. If Nx should become
impulsive, no
0,
impulsive.
conserve the horizontal momentum. VCM, right? Capital M into U is equal to capital M VCM plus this will be L by 2 omega plus VCM plus small m into L by 2 omega plus VCM. This is the momentum of small m. This is the momentum. Now listen, he is asking you at what distance should it strike. So it will not be L by 2, it will be X. Find out the value of X is this question. At what distance should it strike so that the momentum remains constant? So that means this will not be L. Third bit may he is not telling you that it will strike at the lowermost point. Find the value of X is what he's telling.
Sir, I had one more. 39 is the second one.
Thirty
9.
a small ball of mass M suspended from the ceiling of a point 2 by a thread length L moves along a horizontal circle omega relative to which the point does the angular momentum M of the ball remains constant. Find the magnitude of the increment of the vector of the ball's angular momentum relative to the point 2 picked up during half a revolution. Class notes, conical pendulum. I have done this very much in detail. It's a long lecture. About O, about C. 1 second, wait, I'll show you that on the YouTube lecture so that you can go through it. I'll have to tell you the lecture number. And this is a long story because half a lecture to explain that. Yes. The rotation guide, no, the rotational guide. I think lecture number 22 or 23.
Yes, sir.
1 second, wait and see. (23) only यार, 22 में है नहीं, अभी अभी देखा है.
सर मिल गया लेक्चर 24.
24? हाँ, right. Lecture number 24. It's a long story, you'll have to go through. Now, how many of you are there for exercise 1 of the booklet? What was the sequence decided in the class? What did we think we'll do after exercise 5?
Sir, 1.
Exercise 1. Bolo.
So 37. 47.
49. 9.
61.
70.
85.
79.
Let me complete this first.
84.
Open 1 second, ruko, let me complete this exercise 1 and 2. Where did it start from? 37. में power is torque dot omega, force dot V, right? Torque dot omega, there is a rod is hinged at its center, rotated by a constant torque. Torque is constant, implies alpha is constant, implies omega is increasing. Omega is alpha t. So torque into alpha into t. Torque and alpha are constants into t. Power as a function of time. Power as a function of time. यही तो पूछ रहे हो?
हाँ सर, हाँ सर, आ गए.
47. Theta C through with the cylinder before leaving contact. This I believe I deal with in the class. Now this is the initial situation. Suppose the cylinder rotated like this. This will be mg. This will be mg cos theta minus the normal. It leaves contact, bol rahe ho. This is v and this is omega. That means mg cos theta minus n is mv square by r. Normal force became 0 is my first equation. It leaves contact. Right?
Yes,
So
sir.
you are asking me theta c through with the cylinder before leaving contact with the edge. You will find out theta if you know v. How will you know v? Conserve energy.
Loss in
Yeah,
potential energy is gain in kinetic energy. Here the potential energy is R. Here the potential energy is R cos theta. This is theta, this is theta. mgr minus mgr cos theta is equal to delta K. You know the final kinetic energy, you know the initial kinetic energy. It is initially at rest. Finally, this will be half ICM omega square plus half mv square. You have omega in new variable no yaar. How will you handle V? Omega is equal to V by R. Body is not slipping at this particular point. So V equal to R omega. So from this equation V I substitute here, I will get theta. This point, is it clear to all?
yes, sir. Yes.
Now the trickiest part is 49. I don't know why you asked the correct thing. 48 speed of the center of mass will calculate V. From these two equations, theta you will get, V you will get. There are two equations with two variables. Simplification होगा आपसे.
हाँ sir.
Now theta is asked in 47, V is asked in 48. So those two are done. 49 you are falling for a trap laid there. What was the trap? भाई साहब सुन लीजिए. Once it loses contact, it lost contact at cos theta equal to 2 by 3. Once it lost contact, ध्यान से सुनिए, one single line will change your attitude towards this problem. Once it lost contact, torque about the center of mass is 0. Do you agree with that?
Yes, sir.
Omega will remain constant thereafter. Rotational kinetic energy at that instant calculate करो. उसके बाद चाहे सिलेंडर यहाँ पर हो, यहाँ पर हो, यहाँ पर हो, कहीं पर भी रहे, omega will remain constant as there is no external torque. Now you understood?
Yes, sir.
Yes, sir.
The mistake which you might have committed is loss in potential energy. You equated it to gain in kinetic energy, and in kinetic energy you must have written half mvcm square plus half ICM omega square. Omega V by R you substituted. Wrong. Once it lost contact, rotational kinetic energy will not change. It will remain constant. Loss in potential energy will be converted only into translational kinetic energy. Is this crucial point clear to all?
Yes, sir.
Yes, sir. Yes, sir.
You should be crystal clear about it. It's a well laid trap. In the exam, people fall for this, even if they have solved previously. Forty-seven, 49 is done. 61. What a huge jump. 61 is very easy, in fact. The angular momentum of the spool at time t about the bottommost point. F is equal to how much? 2t. So F into R plus R plus capital R is equal to torque. F into R plus capital R is equal to torque is equal to dl by dt. Torque is dl by dt. 2t into R plus capital R into dt is equal to dl. 2 R plus R integral t dt is equal to delta. This is your answer. देख लो आप.
Sir, it should be F into small r only, right?
थप्पड़ मारूंगा.
angular momentum of the spool at time t about bottommost point. क्वेश्चन 3 बार पढ़ो आप लास्ट में.
Yes, sir. Yes, sir, it is.
$61 just now we discussed. 70 on a solid sphere lying on a horizontal surface, force of F is applied at a height of r by 2 from the center of mass. Initial acceleration of a point at the top of the sphere is no slipping. It should not be difficult. Solid sphere per you are applying a force at a height of r by 2. Am I right? You are applying a force at a height of r by 2 on a horizontal surface. Did he say smooth? No slipping at any point. Nothing is told about the horizontal surface. Not fair. So he's leaving it to our fine judgment. The initial acceleration of the point at the topmost. Now, have a look at it. F into A for a solid sphere lying on a horizontal surface. A force F is applied at a height of r by 2. I must have friction for the body to roll. इतना कॉन्फिडेंटली कैसे बोल सकते हो यार? For a disk we calculated it was r by 2. Do you remember that? For a disk, at what height should I apply a force so that the body rolls on a smooth surface at a height of r by 2? So for a solid sphere there will be friction. I take friction in the forward direction. F plus F is equal to ma. F into r by 2 minus F into r is equal to 2 by 5 mr square into alpha is a by r. Find out alpha from this and a from this. Eliminate friction. Find out friction and a are the two variables. R. So F plus F is equal to ma. F by 2 minus F is equal to 2 by 5 ma. Add both of them. 3F by 2 is equal to 2 by 5 plus 1. 1 plus 2 by 5 ma. 7 by 5. Why am I writing this? 7 by 5. Right? A is equal to 5 3 15F by 7M. 14M. This is A. Then find out alpha. Alpha is 15F by 14mr. Now you want the acceleration of this point. This will be A plus R alpha. A is known, R alpha is known. Substitute to get the answer. Initial acceleration of a point on the top of the sphere is. And why did you take rolling condition? He said no slipping. If it is rolling, it is A by R. What makes you say there is friction? I already have the information that when I apply a force of r by 2 for a solid sphere, it will not roll on a smooth surface because at r by 2 it rolls for a disk. Moment of inertia you change, the value will change here. Smart move, right? 70th is a good question. So go to the next question, 79. Two equal masses each of capital M are joined on a massless rod of length L. Now an impulse MV is given to the mass M, making an angle of 30 degree with the length of the rod. Angular velocity of the rod just after imparting the impulse is J into R perpendicular is delta 79. J into R perpendicular is delta L. Take about the center of mass. ICM into omega minus Z. You have given me J. R perpendicular के लिए resolve that parallel to the rod and perpendicular to the rod. Now you are telling me this is the rod. You are applying an impulse this way. This will have a horizontal and vertical. This will give me no angular impulse about this, because this is passing through this. This into this perpendicular distance will be ICM into omega. Yes or no?
Yes, sir.
No. 85th one is a good one and an important problem. Listen carefully. Uniform rod AB of length L and mass M. Uniform rod AB of length L and mass M. This is the uniform rod. Is at rest on a smooth horizontal surface. An impulse J is applied to the end B. Right? Perpendicular to the rod in the horizontal direction. Speed of the particle P at a distance of L by 6 from the center towards A of the rod. Right? From the center towards A at a distance of L by 6. First of all, have a look at it. J will be equal to just after the J. Center of mass is moving with VCM and it has an omega in this direction because of J. J is equal to M into VCM. First equation, are you clear about it? This is an important problem. Please concentrate. J into L by 2 is ICM omega minus Z. Are you clear with both the equations?
Yes, sir.
Right? Now that you know omega, they gave you some time. In that time, find out the angle by which this rotates. Because I know the answer, I am telling you directly, it will rotate by 90 degrees. I know the answer, hence I'm. If not, once you know omega is constant, time is given. Will you be able to calculate the angle by which it rotated?
Yes, sir. Omega t.
Right? Here it turns out to be 90. Once you have that 90 degree rotated by 90 degree, this will be L by 6 omega and this will be VCM. L by 6 omega is with respect to center of mass plus velocity of center of mass with respect to ground. Is velocity of this point with respect to ground?
Yes, sir.
Yes, sir.
Resultant of these two ले पाओगे?
हाँ, sir.
Understood the problem?
Yes, sir.
It's a good and a tricky one.
सर एक 84 भी था.
84. A uniform rod of mass M has an impulse applied at right angles to one end. If the other end begins to move at speed v, the magnitude of the impulse is. Now actually you'll be able to solve that. Have a look at it. This is a rod.
You're applying impulse J. First equation is J is equal to M into VCM. Second equation, J into L by 2 is ICM into omega. Now he's telling you the other end. This will be VCM, this will be omega. Velocity of this will be VCM minus L by 2 omega, which he gives us V. The other end starts moving with a velocity V. That means L omega is backwards, VCM is forwards. VCM minus L omega is V. That's what he's telling you. Magnitude of the impulse J calculate करने के लिए बोल रहा है. एक दो तीन equations, तीन variables. What are the three variables? VCM is one variable, omega is one variable, J is one variable.
Yes, sir.
Again, next week we will have one such type of doubt lecture to clear your backlog doubts. Exercise 1 maybe, I think there are a few problems left over. Exercise 2 and 3 to be done. Right? And then we will complete HC. Don't worry about it, I'll finish it off. Wait. Saturday. But Saturday, are you people okay? Do you have any TWT on Saturday or Sunday?
No.
Saturday evening, are you people okay? 7 o'clock to 8 o'clock? Done. So Saturday evening, we'll finish off the booklet. HCV will do it in the next. Okay.
So what about assignment 4?
What for?
Assignment 4.
Assignment 4, I will take the discussion, provided if you people have done. किया है आप लोगों ने? How many of you have done?
नहीं किया but ऐसा
Assignment 4 online lecture में ही लूंगा. Class में नहीं लूंगा because many might not have done that. So only people who are interested will come. So after HCV, remind me once. I have given you rotation assignment 4.
Yes, sir.
All 3 sections or only one?
सर 3 को दिया है आपने.
हाँ तो मतलब सभी को दिया है. मतलब सभी को दिया है. Assignment 4, I don't think you will be able to do it on your own. I'll have to discuss. So once HCV is over, remind me. I'll discuss. Electrostatics will take some time. By then I'll finish. एक वीक HCV करेंगे, एक वीक assignment 4 करेंगे तो भी हो जाएगा. Because electrostatics will take some time. Gravitation and electrostatics का doubts मैं class में ही ले लूँ. Right? Chalo, see you people in the next class. Good night.
bye sir. Thank you sir.
Bye, sir. Thank you, sir.
Thank you, sir.